Today we're looking for a positive integer with this property. So that means a number greater than or equal to 1. Now, of course, 1's not going to satisfy this condition that it's divisible by each of the first 19 natural numbers. Okay, but this is the definition of a natural number. 0 is not included. Okay, now let's move along. Now, since we'll be working backwards, we know that we need 2 to the 4th in the factorization of our n. So we're looking for an n that is divisible by each of the first 16. Well, that includes 16, so we have to have 2 to the 4th. Okay, but 2 to the 4th times 3, and I could have just written down 2 to the 4th, but I just went ahead and did 2 to the 4th times 3. 2 to the 4th gives us all the multiples of 2, 2, 4, 8, 12. Not all the multiples, but it gives us 2, 4, 8, and 16. Now, if you allow for 3, you end up getting 6 and 12 also. Okay? So you see how we're just working our way along. Now, what's missing here? 9. So we change it to 3 squared. All right? Now, you just take a look here. Quite a few of the numbers have been represented already, but the 5 is not there. So we put 5 in, but we get the extra value that we have 10 and 15 because of the presence of a 3 here. Again, these are just divisors. I'm listing all the divisors of the number so up to this point. Okay, so you can see how the new numbers 5, 10, and 15 happened. Now we notice 7 missing from this list along with 14, and so you add 7. It's very straightforward, albeit tedious. Now, so what are we missing here, folks? We're missing 11 and 13. Okay, so we need to include those numbers here. 2 to the 4th times 3 squared times 5 times 7 times 11 times 13. So this is our answer. And I could just leave it like that. But this turns out to be a kind of a fun problem to calculate without using a calculator. Now, note that, let me just write this down, and it's a fairly easy computation. 7 times 11 times 13 has kind of a computational advantage to it. If you multiply that, and this is easy to do in your head really, this is 1,001. 7 times 11 times 13 is 1,001. And 1,001 is a fairly special constant because it's easy to do computations with it. Okay? So notice that if you had, let me just write it like this, 2 cubed times 3 squared times 5, like this, folks. And notice 7 times 11 times 13 is 1,001, so you have 1,001 right here. Now, what's really cool about this is this 2 cubed times, let's see that, what is that, 8 times 9, that's 72. Okay, so what is that, and then times 5? What does this particular product give you? This is 2 cubed, which is 8, and 8 times 9 is 72. Okay, then you multiply by this, and what does that give you? Well, one way to think of it is to also look at it as that this 36 would be included in this, right? 36 would be included in this, and so this would be equal to 360 times 360. Well, not, excuse me, just 360, 360. Now you're saying, how did that happen? Well, one of these 2's is going to go with the 5 to give you this trailing 0, right, folks? You said one of these 2's will go with this 5 to give you the trailing 0 right here, the last 0 in the 6-digit number. And then you would have 2 squared times 3 squared, which is 36, right? So now you multiply 36 times 1001, you get 360, and that kind of neat. It's a mirror image of itself just pushed over 3 positions to the left. All right. But note that our number is 2 to the 4th, right? So this would, in other words, this number is going to be exactly double this number, okay? So you get 720, which is kind of cool. This is in an age where so many people rely on calculators to do the computations. We were able to do this without a calculator. So there's our answer. 720 is the least integer that is divisible by the first 16 natural numbers. And this would give us an easy recipe to do the first 17 natural numbers, because all that would change would just be you attack a 17 on here, right? And so the answer for the first 17 would be this number times 17, which would be harder to do mentally. But anyway, let me know what you thought. I thought it was a fairly cool problem.